Okay, so for this video, we're going to be solving radical equations. And for the first page of notes, the front side, we can go ahead and use the same steps that we've been using to solve equations all along, which is to use order of operations backwards. So I think the first two are a little bit easier than I want. So, and we're not going to do all of these examples. I don't really think that we need to. So I'm going to go ahead and start us off with example number 3. So remember, the first thing we do is we look to see if there's anything that we could add or subtract to move numbers away from the variable. We can't get at the 7 because it's protected by the square root, which is the grouping symbols in this case. So I'm going to subtract the 10. So I've got the square root of a plus 7 equals 1. Then I'm going to look to see if there's anything that I could multiply or divide to the other side. In this case, there's no coefficient here. It's not a fraction, so there's nothing that I could multiply over. There's no coefficient to divide over. Problem number 5 is one where you'd have something that you could divide over to the other side. So step 2, we're going to skip on this one. Next, I'm going to look to see if there's an exponent that I could get rid of or an exponent I could introduce. In this case, I could introduce an exponent. I can introduce a squared to get rid of the square root. I'm going to do that on both sides, squared. So the squared and the square root cancel each other out. So I get a plus 7 equals 1 squared, which is just 1. And then now that I've gotten rid of the exponent, I can get inside. It's not parentheses in this case, it's the actual radical, but when they say parentheses, they really just mean the grouping symbol, which in this case was something other than parentheses. But we are inside the grouping symbols, and now I can go ahead and just do, go back to the beginning, add or subtract, which in this case is the 7. And so I have a equals -6. Now, in the instructions, it says to check for extraneous solutions. Extraneous solutions are solutions that you can find, but they actually don't work for the problem. And so with square roots and cube roots and all that, we always have to be careful. Square roots, fourth roots, sixth roots, all those even number roots, especially because we're not supposed to be taking roots of negative numbers. So what I'm going to do is I'm going to take the -6. I'm going to store it. If you guys remember that store button, I'm going to store -6. I'll go ahead and use my actual letter as the letter A, alpha A. You can use X for every problem. It doesn't really matter, but if you want to use the actual letter, you can. So the A is right above the math button in green. So I hit alpha A, so I stored it as A. And now I'm going to type 10 plus the square root of alpha A plus 7. And if this is not an extraneous solution, if the solution actually works, then this should equal 11. If it is an extraneous solution, then I'm going to have some sort of issue where it's going to say error because I would have gotten the square root of a negative. So since it equals 11, I know that my answer is good. Okay, let's go ahead to the next one, number 4. So first, I'm going to add or subtract numbers to the other side. So I'll subtract the 10. So I've got the square root of 6w minus 5 equals 3 minus 10 is -7. There is nothing for me to multiply or divide to the other side, so I'm going to skip that step for now. Third step, is there an exponent that I could get rid of or an exponent that I could introduce into the problem? The exponent that I could introduce is a 2. I can square both sides to get rid of the square root. I've got 6w minus 5 equals 49. The last step, I am now inside my grouping symbols that were over here, so I'm going to go back to the beginning. Is there something I could add or subtract that would get the variable closer to being alone? Yep, I could add the 5. 6w equals 54. And then I can multiply or divide by 6. W equals 9. Okay. And so now I'm going to do the check step. So I'm going to take 9, I'm going to store that as W is above the minus sign, so I'm going to do alpha minus. So 9 is stored as W. And now I'm going to type square root 6 alpha minus 6W minus 5 plus 10. And if this is a good answer, then it will just equal 3. If there's some issue, if this is an extraneous solution, then I will have, it will show, my calculator will show that I'm going to have a square root I'm square rooting a negative number. So it said 17. So that means that this is not a good answer. That's an extraneous solution. It did not equal 3. So I'm going to write extraneous solution. Did not equal 3. Okay. All right, let's move on to the next problem. So it didn't do what we predicted. That's how you can kind of tell that your answer is not working the way that it should. Okay, so basically, and that's because of the way that the square roots work. If you guys remember, we were talking about dead horses. We would have needed the negative version of this plus 10 to work to equal 3, and it didn't. It's not the negative output, it's the positive output, and that's why it didn't work, basically. So, so this is what we call an extraneous solution. So don't be confused when it happens. Just know that if you did everything right and you plug the number in and it doesn't work, that means it was an extraneous solution. All right, let's go ahead and do a problem that looks like number 5. So if you don't like the problem having the exponent written as a rational, like the 1/2, then you can rewrite it as a radical. It doesn't matter. So you can do it either way. So I'm going to go ahead and write my order of operations backwards. So we've got, first we're looking to see if we can add or subtract something to the other side. In this problem we cannot. The -9 is being multiplied, so we can't do step 1. Step 2, is there something we could multiply or divide to the other side? Yes, we can divide a -9. So 4 equals c minus 12 to the 1/2. Third step, is there an exponent we could get rid of or an exponent we could introduce to get rid of something? And the answer to that question is yes. To get rid of an exponent of 1/2, all you have to do is raise it to the second power. If that does not feel comfortable to you, then you could rewrite the problem. You could say 4 equals, remember 1/2 is a square root, c minus 12. And then you could say, yep, let me go ahead and square each side to get rid of that square root. So either way you write it is fine. We're going to get 4 squared is 16. If we were doing it this way, we would multiply our exponents together. 1/2 times 2 is 1. C minus 12 to the 1 power, that's normal. We are used to seeing parentheses to the 1 power. That's when you don't really need the parentheses at all. You can just write 16 equals c minus 12. Over here, if we did it this way, we would just say, oh, 16, and then the squared and the square root cancel out. So either way you choose to write it is totally fine. You can leave it this way if you're comfortable with that, or you can rewrite it as a radical if you would rather do that. And then last step is the same for both. We're going to go ahead and add the 12 to the other side because we are inside those grouping symbols. So over here we actually had the parentheses that we got inside this time. Over here it wasn't really parentheses, it was just grouping symbols. And then we go back to the beginning of isolating the variable by adding or subtracting something to the other side. We are adding the 12 over, and we get c equals 28. Okay, so again, I'm checking for that extraneous solution. C this time is above the program button. You can see it in green, so I'm going to do 28, storing it as C. And I'm going to type negative 9 times c minus 12 to the 1/2. I know that my answer is not an extraneous solution if this equals negative 36. And it does. So the answer is good. Okay. All right, let me go ahead and try number 6. So first step, is there anything I could add or subtract to the other side? There is an 11 that I can go ahead and subtract over. So I have 7p minus 1 to the 1/3 equals negative 4. Is there anything I can multiply or divide to the other side? There is not. Is there an exponent I could introduce or an exponent I could get rid of? Yes, there's a 1/3. I can take this, I can raise it to the 3rd power. Or if you were uncomfortable with that, you could rewrite the problem as the 3rd root. 7p minus 1 equals negative 4. And then we would do the same thing. We would raise it to the 3rd power. Okay, so here 1/3 times 3 is 1, so we have 7p minus 1 to the 1. Negative 4 to the 3rd is a negative answer, negative 64. So cube root and a cube cancel out. 7p minus 1 equals negative 64. Fourth step is to get inside the parentheses, which we can do. And at this point, we're going all the way back to the beginning. Now to get the variable alone, we can add or subtract something to the other side. 7p equals negative 63. We can divide by 7. P equals negative 9. And so we just want to check and see if that is extraneous or not. So negative 9 stored as P. The letter P is above the 8, so I'm going to say alpha 8. And then to type that problem in, I've got 7 alpha 8 minus 1 to the 1/3 plus 11. I want to make sure that it equals 7. And it does, and so that is a good answer. All right, let's go ahead and try number 8. So first, we're going to look to see if there's anything that we could add or subtract to the other side. If you're feeling comfortable with this, then for this problem, I would say go ahead and pause the video right now, work ahead, and then unpause the video and see if you get the answer right. So first, we're going to add or subtract. So we're going to subtract the 18. So we've got negative 4. Square root of 43 minus 3x equals negative 20. Then we're going to see if there's anything that we can multiply or divide to the other side. Negative 4. So square root of 43 minus 3x equals 5. Then we're going to see if there's an exponent we could introduce or an exponent we could get rid of. We can square both sides. So 43 minus 3x equals 25. Oops. Fourth step is parentheses. Those are our grouping symbols, which we just got inside, so now we're going back to the beginning. We can add or subtract the 43 over to the other side to get the x alone. 25 minus 43 is negative 18. And then we can divide by the negative 3 to get 6. Okay, so let's check our answer. So I'm storing the x. equals -2. So that is a good answer. Okay. All right. On the front of the notes, put an X through number 1, number 2, and number 7. Number 1, number 2, number 7, you do not have to do those. 1, number 2, number 7, put an X through those. Okay. For the other side, let's go ahead and look at number 10 next. So these problems are going to be a little bit different. We are not just isolating a single variable, so order of operations backwards does not quite work the same if you have a variable on both sides of the equations, or both sides of the equation, singular. And so here you can kind of look at the directions that Gina Wilson gave you. So here we're going to do our best to, well, the radicals are kind of isolated. If you have a radical on both sides of the equation, then you can't really do much. But if you have only one radical in the problem, then you're going to do your best to isolate it on one side if there's only one of them. And then you're going to raise each side of the equation to, to the power. So if it's a fourth root, you're going to do to the fourth power, square root, square, raise it to the second power, third root, raise it to the third power, and then you're going to solve the equation. So anytime you only have one variable, though, the best way to know the correct order for solving an equation is to do the order of operations backwards. So the reason I did such a thorough job of going through this with you guys is because some of you guys have been doing these steps out of order and getting the answers wrong for some of your equations. So this is good, especially for some of you guys who rush your steps and don't show work. Some of you guys need to go back and write this on your paper because you're getting answers wrong because you're not doing this. All right, so these ones, we are not going to be doing the order of operations backwards as much because it doesn't really work the same when you have a variable on both sides. So for this one, let's go ahead and do number 10. 9 and 10 are very similar, so we're going to do number 10 because it's a little bit, more difficult, I think, because it's a fourth root, or maybe it just feels that way, I guess, to me. So for this one, we're just going to take it, we're going to raise this side to the fourth power, we're going to raise this side to the fourth power. So that's going to cancel out the fourth root. That's going to cancel out the fourth root. And so we're going to have 27 minus 2d equals d minus 3. So at this point, our goal is to get the variable on one side and the letters and the numbers on the other side. So I'm going to go ahead and just add the 2d over. So here we're just solving an equation. And then I'll add the 3 over. Okay, so basically I lied. This wasn't very hard. Divide by 3. Now, we do still need to check to see if this is an extraneous solution. I guess the only part of this problem that's really more difficult than number 9 is the checking. This one's a little bit more complicated to type in. So I'm going to go ahead and store 10 for D. So D is this button right here. So store alpha D. Okay, so I'm going to do the fourth root. So remember, for your fourth roots, you have to type the 4 first. So 4 and then the math button, number 5. So fourth root, 27 minus 2d. And I need to make sure that whatever this decimal is, or whole number, that needs to be the same as when I type it on the right side. So fourth root, math button, d minus 3. They got to be the same. So my decimals are the same, so this is not an extraneous solution. This is a good answer. Okay. All right, let's go ahead and do 11. So 11 and 9 are very similar. You've got square roots on both sides, but 11 is a little bit more difficult because it has coefficients. So let's go ahead and do this. We're going to have to square both sides. So for this one, when we square the left side, we're going to get 4 squared is 16, and then you can say the squared cancels out the square root, and we get 3q plus 15. On the right side, you can get 12 squared, which is 144, and then you can square the square root and get q squared. Not q squared, just q. Sorry, my bad. Just q. So the square root and the square canceled out. So I'll go ahead and just distribute the 16. So 16 times 3 is 48q plus 16 times 15 is 240. And then that was 144q minus 48q. So we've got 96q. And so q equals 2.5. And now we just need to check and see if that solution is extraneous or not. So 2.5, I'm going to store that as q. Q is above the 9 button, so I'm going to store that as q. For square root 3q plus 15, 12 square root q. That answer is good. All right, let's jump down to number 14. So here's one, we have a square root, and we have the other side does not have a square root. So if you have a situation like this, you're going to do what you can to isolate the square root. So we can subtract the 7a to the other side to get this square root isolated. So let's go ahead and do that. So 12 minus a equals a. So now the square root is isolated on the left side. It's going to make it a little bit easier for us to handle the problem. It's not that we could not have handled the problem before, it's that it would have been more difficult to do it. And you'll see because we're going to do number 18 together, and that one is going to kind of show us what would have happened. So let's go ahead and square both sides. So squared. So on the left side, the square root and the squared cancel out. And we get 12 minus a. On the right side, we get a squared. And what just happened is we got a quadratic. So if you guys recall, quadratics have two solutions. And we get those solutions by factoring, using the quadratic formula, completing the square, whatever. And so I'm going to go ahead and try to factor this. And whenever we factor, we want the squared form. We want this part to be positive. So I'm going to add this a to the other side. I'm going to subtract the 12 over. So I've got 0 equals a squared plus 1a minus 12. So I'm looking for two numbers that multiply to negative 12 and add to positive 1. Two numbers that multiply to negative 12 that add to positive 1. So those two numbers are 4 and negative 3. So my factors are a plus 4, a minus 3. And if you guys recall, if this is what my factors are, that means that my two answers are a equals negative 4, a equals positive 3. So I need to check both of those answers and make sure that they work. Now, when I check my answers, I'm going to check my answers against the original problem, not anything else. Always check back with the original problem. So I'm going to go ahead and check the negative 4 answer first. I'm going to do negative 4, I'm going to store it as a. square root 12 minus a plus 7a, and I'm going to make sure that equals 8a. So negative 4 does not work. Okay, now I'm going to check 3. I'm going to check that one, and then that one. So 3 was okay, but negative 4 didn't work. So we only had one extraneous solution on that problem. Okay. Let's go ahead and try number, let's go ahead and try number 15. All right, so for number 15, this one we have our radical is isolated, and then we have something that's not a radical, so I'm going to go ahead and square both sides. Squared, squared. So when I square the left side, it just gets rid of the radical. 6m minus 38, that's pretty easy. On the right side, when I square that one, I actually have to FOIL it. So m minus 5 times m minus 5, that means there's 2 of them. So I have m times m is m squared minus 5m minus 5m plus 25. Okay, so 6m minus 38 equals m squared minus 10m plus 25. So again, I have a quadratic. I have a pretty good feeling that most of these are going to be quadratics towards the end here. So I have a quadratic. So my options are, again, I can factor, I can use a quadratic formula, I can use completing the square, I can solve by taking square roots, all that stuff from the last unit that you guys love so much. I'm going to keep this term positive. I'm going to try to factor it if I can. So I'm going to minus the 6m and add 38. So that's 0. So 25 and 38, 63. So I'm looking for two numbers that multiply to a positive 63 that add to a negative 16. So those two numbers would be negative 9, negative 7. So I have m minus 9, m minus 7. So my two solutions are positive 9, positive 7. So I just have to plug these in, see if they work. And you truly cannot skip this step because so far, like, we haven't really noticed, because here we've got like a negative answer that works, big positive answer that works, positive answer that doesn't work, negative answer that works, negative answer that doesn't work. So we haven't really been able to make a prediction about which answers work and which ones don't. So we just have to check all of them. So we're going to store a number as m, and then I've got square root 6 m minus 38. I want to make sure that equals m minus 5. Yep. And then 7 stored as m. I'm going to plug it back in for both of those. 2, 2. They both work. So 2 answers this time. Okay. All right, similar procedure for number 17. We're going to do 17 and 18, then we're going to be done. So squared, squared. So the squared and the square root cancel out. Number 15 and 17 are basically the same. So y squared minus 11y minus 11y plus 121. So we're running into another factoring one, so I'm going to go ahead and make it equal 0. So we're looking for two numbers that multiply to positive 70 and add to negative 17. So negative 10, negative 7, y minus 10, y minus 7. So we've got square root 51 minus 5y and y minus 11. Okay, so 10 does not work. Ten does not work and 7 doesn't work. So we had two solutions. We tried both solutions. Neither solution worked. So for this one, we're going to say no solution. So it is possible to get one where the answer doesn't work. And this is actually what we would write for number 4 as well. We only had one answer for number 4 and we crossed it out, and then I forgot to have you guys write this. So for number 4, we should have written no solution there too. Okay. I want to do number 18 because number 18 is a funky looking one. It kind of looks like it might be like number 17, but this has a radical over it. So I think at this point we kind of know how this is going to go, maybe. We're going to square this. We're going to square this. So the left side we already know. Okay, the squared and this are going to cancel out. We're going to get x plus 9. The right side is going to be kind of weird because we have to write this twice. Root x minus 1. Root x minus 1, and we have to FOIL it. So root x times root x is, root x squared. Okay. And then we got minus root x minus root x plus 1. Okay. So root x squared, the squared and the root, they cancel. So that's just an x. And then we got root x and root x, that makes minus 2 root x plus 1. Okay, so what just happened is this problem kind of turns into a double because our goal was to make it so there was no radical in the problem, and we started doing that, and then we still have a radical in the problem. So we're actually going to have to do the process again. So what we're going to do is we're going to try to isolate this on the right side. So I'm going to subtract x. Okay, so that's interesting. And then subtract 1. So my goal is to isolate this. So I have 8 equals negative 2 root x. Okay, so I can divide by negative 2. And then actually at this point, I'm almost done. I can just square both sides. So negative 4 squared is 16. 16 equals x. Now, before I conclude this is just the answer, I definitely need to check this for an extraneous solution because weird stuff happened in this problem. So I'm going to do 16 stored as x, plug all this in, see what happens. So square root of x plus 9, I want to make sure that's the square root of x minus 1. It is definitely not. So this is an extraneous solution, and then for this problem we're going to say no solution. We did the work, we just couldn't get there. Weird problem. All right, so for the rest of the notes, we're going to put an x through 9, 12, 13, 16. Put an x through 9, 12, 13, and 16. You do not need to do those. 9, 12, 13, 16. Put an x through those.